Right, good morning everyone. Sorry, I was just sorting the camera out there. A little bit wonky off yesterday. Good to see you down. It's going to be science this morning, as you can see. Okay, just before we start, I'm not going to take credit for this. My fiance asked if she could do it, so I'll let her do that. Okay, she would kill us if I took praise for it. So, anyway, we're going to be starting the lesson. Let's have a look. 3 minutes time. We're going to start at 10 o'clock. Give people a chance to get down. Good morning to everyone who's already there. Down in the chat, I've seen you been there for a while. So we've got Tom, Milo, Isabel, Sophie, William, Jude, Evie. I've seen lots of people down in there in the chat. If I missed you out, sorry. Like I say, there's lots of people there. But it is great to see you down. Cool, exciting lesson today. We're going to start on a new topic. We're going to get started in 2 minutes or so. Okay. Right, sorted. Right, okay, just a minute or so, and we will be getting started. Okay. Let's see who is in the chat. Morning, Emily. Let's have a look. Anyone else that I've missed out there? Morning, Heidi. Good to see you. Morning, Seb. Morning, Lucas. Morning, Ollie. Morning, Charlie. Morning, Francis. Morning, William. Morning, Millie. Good to see you. Morning. Some of you I can see there, but I don't know what your names are because you haven't got your real names, so your usernames there. Morning, Amelie. Morning, Shay. Morning, Christian. Morning, Jack. Good morning, YouTube, apparently, in the chat. Morning, Lucas. Morning, Leonie. Morning, Lucas as well. Morning, Jake. Your boy Yeti, I don't know whether that's... I think it might be Joseph I saw earlier on. Good morning, Mrs. Rice. Good to see you down in the chat. Let's have a look, minute or so, and then we will get started. Morning, Freya. Good to see you down. Morning, Alfie. Well, not see you. You know what I mean. Good to have you down here. Morning, Epic Waffles. Great name. Morning, Jude. Good to see you, mate. Morning, Iris. Morning, Leah. Morning, Alfie again. I think I said morning, Alfie. Okay, loads of people in the chat there. And obviously, I know there's a lot of you that watch the videos that aren't in the chat as well. So, good morning to you as well. Okay, I don't want to be too favouritism under the chat, okay, because I know a lot of people can't get on the chat because of the accounts and things, I don't know. Okay, but good morning to you as well. And obviously, if you're watching on the replay, if it's not in the morning, good afternoon. If it's not in the afternoon, good evening. And if you're watching in the middle of the night, what are you doing? Go to sleep. Okay, so it is 10 o'clock, so we are going to get started, okay. All right, so today, like we said, it is science every Wednesdays when I try to do science. Obviously, my schedule will change sometimes if I'm in school looking after key workers' children, but not this week, so we've got science on a Wednesday. However, this week is a bank holiday on Friday, okay? So the only video I'm going to be doing on Friday is the stay-at-home street party, which obviously I've told you about. It's on my page, it's on my Facebook. If you're new to the chat, on Friday we're going to have a street party between 3 and 4. I'm going to be playing some music. Well, DJing sort of, maybe not really as much as what I normally do on stay-at-home school discos. But I need you to help me choose a song, so comment on that. I'm going to mention that at the end, because children, the adults are picking more songs. I can tell by the song choice, so you need to get your choices down to make sure they are not taking it over. Okay, but we'll talk about that later on. I'm not doing a lesson on Friday with it being a bank holiday, because we wouldn't normally be in school anyway. So I moved my Friday lesson to tomorrow morning, which means today, as well as science, we're going to be looking at our topic lesson, which is people who change the world. Okay, and the person that we're going to look at is Tim Peake, because he links in with what we're going to be doing in science. Okay, you should all know who Tim Peake is, I think, because he was on the news a few years ago and everyone knew who he was. But if you don't, you will find out later on, so don't worry about that. I'll tell you where the worksheets are for the lessons and everything, and the quizzes and things like that at the end of the lesson. Let you know where to get those. If you're stuck in the lesson, comment on the video, not in the chat, please. If there are teachers there, they might catch it, but they might miss it. If you put a comment on, we will definitely see it. And obviously, if you're watching the replay, you won't have the chat, it will just be the comment, so pop it in there for me. Or you can get in contact with my Twitter, my Instagram, or my Facebook, which is Mr. Biggins123. Send me a message or whatever it is on those. Few people do that when they're stuck with work, which is brilliant. It's great that I can help those guys. And where you get the worksheets from the Padlet, you'll be able to get in contact with us on there if you are stuck. Okay. And obviously after the video, I'll stick around for a little bit if anyone has any questions on what we've learned. Firstly, last week we had a quiz at the end of the lesson on Kahoot, and I'm going to announce the top 3. Last few times I've done this last lessons, there was loads of people got 100%, but there was only one persons got 100% this time, and it was I'll go for third place first. Actually joint second, so there was 2 people who got 92%, so I think it means they got 1 question wrong, and that was Jack S and Isabel. Okay, didn't have an initial Isabel, so I don't know which Isabel it is. You'll probably know if you only got 1 wrong, but round of applause for that. Okay, and the 100% was the Ray brothers. Again, judge's inquiry out there to his brothers, so there's more than 1. Do we give them it? I'm going to say yes, because they did get 100%. Okay, but well done for that as well. Okay, there is a Kahoot to go with this, so pay attention, make notes, and see if you can get on the leaderboard for next week. And last little thing, I know you're waiting for TikTok. I'm still trying to learn the dance. As soon as I know it, I will get it up. Okay, Sophie Leah, I'm working as fast as I can. Remember, my school, my class, keep working on Reading Plus, keep working on Mathletics, okay, working really hard on those, because once I've done those 2 dances, I'll be letting someone else choose my next TikTok that I'm going to look an idiot in, okay. So today we are going to start looking at space and our solar system, and we're going to start looking at the end, we'll look a little bit at Tim Peake. Okay, we're not looking in great depth because this is just our first lesson. As the lessons go on the next couple of weeks, we will start looking more in depth. So you might have questions on certain things, and I might say just wait till the next lesson and stuff. Focus on what we are learning in there today. So we're going to have a brief overview. So firstly, we're going to look at the planets in our solar system. Okay, so this is our solar system, sort of. It's a picture of our solar system, and I want you to tell me, okay, our solar system firstly is made up of 8 planets. When I was young, it was made up of 9 planets, but they decided that Pluto isn't a planet anymore, so what are you going to do about it? But made up of 8 planets, and it's everything in our solar system. So the planet, it's 8 planets, it's moons, asteroids, comets, meteoroids, what you see as shooting stars when you see them going across the sky. Not actually stars moving, they're actually meteoroids burning up in the atmosphere really, really quick. Okay, so all those together, that's our solar system, everything in it. Okay, now I've got a picture on the board, okay, that represents all the planets. They're not this close, I'm going to talk about that later, but we have all the planets represented. Can you name all of them? Okay, so in the chat there now, can you pop down the names of the planets? What planets do you know? Any planets you know, can you pop them down? Okay, if anyone writes them down in order, okay, in their chat, double points for you. Okay, so we know this is the sun, which isn't a planet, and we'll get onto that later. Okay, so we have the sun there, but then we have our 8 planets. Okay, we have a little asteroid belt between these 2, and what are their names? Okay, I'm sure you're going to get them all, but I'll be really impressed if anyone gets them all in the right order without Googling as well. Okay, So, who is that? Is that Alex? Well done. Alex was the first one who's got them all in the right order. We've got Alfie there as well. If you watch on the replay, so just write them down then when we put them on the board. So we've got all the planets there. Well done, Emily. Okay, I've got someone there. I've just seen a message has popped up on Instagram asking how that you get into the chat. I'm pretty sure you need a YouTube account and YouTube page to get into the chat. Okay, so that has to be set up, and then it'll let you in the chat. You don't have to put any videos up or anything like that. I'm pretty sure those are the rules. I don't know why they're the rules, but they are. Okay. Someone's saying yes, you do. So yeah, that's right. So we've got all the planets. Okay, lots of people mention them. So our first one, closest to the sun, is, I'm going to write this a little bit bigger actually, and I'll do one above one. Didn't want to take all my board because I had to write. I knew I had to write on it. So our first one, Mercury, and that is the one, and that is closest to the sun. Then here we have Venus. Then this is our little planet. Okay. Earth. Where should we put this one? Then we have the next planet, which is Mars. Mr. Biggins can write. Mars. And then we have the biggest planet in the solar system, Jupiter. Okay. Then we have Saturn. Then we have Uranus, no jokes. Then we have Neptune. Now I did see someone there has popped in Pluto. Now I mentioned when I was a child, Pluto was classed as a planet, okay? But what they've done since then, I'm not sure exactly what year it was, is they reclassified the planets, which means I had looked at them again, and they said that planets had to be bigger than Pluto actually was, so we don't count it as a planet anymore. Because it would have been the next one, okay, it's that far out. It was harder to see how big it was, things like that. And I think they eventually found out that there was other stuff in our solar system that is going around the sun that is actually bigger than Pluto, that isn't classed as a planet. So we don't call it a planet anymore. But I'm very sad because Pluto is a great planet, just in my opinion. So, now there are people use different ways to remember the planets. Now, I haven't really got one. I've learned them now and I know them, okay? Because the way I learn them is what we call a mnemonic, okay? A mnemonic is where you use the first letter of each planet or each whatever it is to make up a little rhyme. Okay, now I can't remember mine exactly off the top of my head that I learned, but mine obviously had a P at the end. So mine doesn't make sense anymore that I learned when I was young, okay? I know it had many jam sandwiches, okay? So you can think of your own, you can have a look some online, but I always think when you make a mnemonic, if it's a one that you make up, you remember it more, okay? So you could have a think of your own mnemonic, okay? My very eerie mom jumps sideways under nets. Just off the top of my head, I don't know. You can think of better, okay? But there are different ways to remember them. Some people can just remember them, which is brilliant. And you can see that they're all different sizes and they're all different distances from the sun. Now we might look at the size of the planets and compare them to each other. And this isn't drawn to scale. I'm just going to say that, okay? So Jupiter isn't exactly this much bigger than Earth and Mars, and vice versa, okay? I've just drawn them so you can see in order. These planets are about the same size. Mercury's our smallest, Jupiter's our biggest, then Saturn afterwards, okay? And then we have Uranus and Neptune at the end there, okay? That are a little bit bigger than these planets. So I've just drawn it roughly to scale. Sorry, my fiance drew it roughly to scale, okay? So they are just rough guides, so you can see, you could look at that and say which one's the biggest, but you couldn't say, oh, it's twice as big or anything like that. We might look at that in another lesson. So firstly, what we're going to look at is the best planet of all, which is Earth. Obviously, it's the best planet of all because we are all on it. So it's the third planet from the sun, okay, and it is the fifth biggest in our solar system, okay. So out of all the planets, we've got Mercury that's smaller, Mars is smaller, and Venus is smaller. Off the top of my head, 1, 2, 3, 4, 5. Yes, so these planets around us are smaller. All these planets are bigger than us, okay. Now our planet is round, but it's not. What we actually call it is not a sphere, okay. We're going to look at 3D shapes, which will be next week actually. It's what we call an. Now this is a mouthful. An oblate. An oblate spheroid, okay. Now what that means is that the diameter, which is the distance from one side, so like there to there, the diameter across the planet would go through the middle of the planet, okay, isn't the same all the way around. Because if we had a sphere, it would be like a perfect circle, okay. Don't know how that's a perfect circle. So our diameter across it, okay, going through the middle, sorry, Mr. B, where's your math skills, okay, would be the same all the way on a sphere, okay. Now what an oblate spheroid is means this might be a little bit squashed. Now I'm going to make it more squashed than it actually is. So you can see that that distance, okay, is bigger than that distance, only slightly, okay, but that's what an oblate spheroid is. Now, if you can't remember oblate spheroid is a great name. If you can't call it a sphere because it's not perfect. Okay. Now the biggest the diameter is, so the fattest the Earth is really, the widest across is across the equator. Now equator is an imaginary line that is drawn halfway around our world as we look at a map. Okay, you might see it's not a real line that someone's drawn on or that is there or anything like that. It's an imaginary line that we use to half the northern hemisphere and the bottom of the hemisphere, okay, and the diameter is thicker. So it's like, imagine if you had a ball, okay, not the one that's got maybe a little bit air out, and if you push it a little bit, if you think about it, it's no longer a perfect sphere, is it? And then the biggest part will be right round the middle as it's sort of coming in on itself, and that's what's the same with our Earth. Now, when we look at the Earth as a planet, we look at pictures, we see it like that, okay, when we see pictures, when we see real pictures, and that looks like a perfect sphere, doesn't it? Perfectly smooth all the way around, okay, but is our planet perfectly smooth? Okay, when we look at it from space, you see all these pictures in space, and you just see a circle, and that's the Earth, so it looks like it's smooth all the way around. Is our planet smooth? And if it is, why? If it's not, why? How can you prove it? Okay, as scientists, remember, you always have to prove what you see. You can't just say, oh, yes, it is. You need to say, yes, it is, and back it up. Or you say, no, no, it isn't, and back it up. Is the Earth smooth? Let's have a look to see what you think. So some people saying no, okay. Let's have a look there. Your boy Yeti said no because of mountains. Brilliant, yeah. So if you think about it, there's mountains, isn't there? Okay, so that wouldn't be as smooth. It would be flat if it was. Any other, like bumps on the Earth, yeah, so bumps on the Earth. So we're talking about mountains, but even hills and things like that. And if you think about it, if you look at your house, you can probably see roads going down, roads going up, roads going down and up. That's not smooth, that's not flat, is it? Okay, we always think of mountains because they're quite jagged. And that's things going up, but what else? Okay, yes, flat earthers might be shocked. Okay. Holes in the ground, yeah, holes in the ground. But what bigger things do we have? The biggest sort of, we could call them holes, more like canyons, more things, on our Earth are actually filled with something. What are they? Have a think. Hills and bumps and stuff like that. We've got man-made things being mentioned there, very brilliant. So really tall buildings. If you have a think, if you just look out in front of you, if the world was smooth, it would just be flat, wouldn't it? But we have buildings as well as man-made. So we have man-made and we have natural. Okay, so natural, our hills, our mountains, things like that. And man-made, our buildings and any other man-made structures, things like that. We've got the Grand Canyon. But I'm thinking about, we're all thinking about things going up. What about things going down? Apart from holes, I don't see loads of holes everywhere. But there is a massive amount of the Earth where it goes quite far down deep. And it's filled with something. It's filled with water, yeah. It's the oceans, it's the seas. Do you think about it when you go to the sea and when they go all the way out, like the Atlantic, the Pacific, the oceans, they go down and down and down for thousands of kilometers, okay? They go all the way down, so we have those dips as well. They're filled with water, but if we took the water out, you would be able to see all those big canyons and big dips and all of those things, okay? So no, the world isn't smooth, although it looks like it because it's when it's really far away, okay? Have a think about it. If you had a ball with a football, you just put it, or a basketball or netball or something, and the leather's starting to come off and you have those little things on it. It's not smooth as it. If you rubbed it, you'd be able to feel the surface got little bumps, okay? But if you had that netball or that football on the other side of the yard and you looked at it, it would just look like a sphere, wouldn't it? Because it would be too far away to see those little things, and that's why the Earth looks smooth when we look at it. Now, the reason our planet and the rest of them are all spheres, or spherical, sorry, I should say, not even listening to my own lesson, is because of a force called gravity. Now, you might have looked at that when you looked at a lesson in forces. I'm not going to go into it too much because this isn't a forces lesson, but gravity is the force that pulls us down towards the Earth and stops us from floating off, okay? It's why when you hold something and you open your hand, it will drop to the floor because of gravity. Now, it's gravity that makes our planets spherical, okay, circles. That's why we don't have square planets and things like that. And I'm gonna. This is said a lot, I think, in lessons, but I don't think many people explain why. So I'm gonna just do a quick little go over of why gravity causes our planet to be a sphere. Now, gravity pulls everything down to the floor. Okay, it's because the force of gravity is coming from right in the center of our Earth. Okay, so if we have our Earth, okay, and gravity there is pulling everything down towards it, okay? Now, the gravity coming out, the force coming from that centre is the same all the way around. So that's why we don't have this bit being further away, that bit being a corner or everything. It's all getting pulled down at the same force around the Earth. You can see, sorry, I'm putting the arrow the wrong way there. So you can see it's all coming down. So have a think. If you dropped, imagine this is some water, okay? If I dropped a stone in there, in that water, imagine I've dropped a stone there, have a think what the ripples would do, okay? And that's our force. The ripples would go out in circles, wouldn't they? Not perfect, but we'd have the ripples going out when we dropped it in. And that's like how our force of gravity works. It goes out in all directions from that center point. Okay, it goes out those ripples, so it's pulling everything in from that center point. So it means that the Earth becomes, over millions of years it has taken, becomes these spheroid shapes. Okay, so that's gravity causes all our planets to be spheres. If you're wondering why we don't have any cubes or anything like that as planets. Now we've had a little look at Earth, and what we're going to move on to is moons. Okay. Now, as well as planets in the solar system, there are moons, okay? And you hear me saying they're plural, so there's not just one moon, okay? So moon is a bit like a smaller planet that doesn't travel around the sun, but rather travels around a planet. So it's a smaller, massive object, okay? And rather, like small planet, rather than going around the sun, like these planets all do, it goes round a planet, okay? And when you say moon, we always say the moon. We're talking about our moon, okay? Popped our moon on. Now, we only have one moon, okay? But we aren't the only planet that has moons. Have a guess, okay? We have one moon. How many moons do you think there are in the solar system going around different planets, okay? Pop it in the chat. If you're not on the chat, just have a think. Tell someone that you're with. Have a write it down. How many moons do you think are in our solar system? Okay, so around all these planets. Okay, and all the planets have different amounts of moons. Okay, I'm going to give you another clue. Mercury and Venus don't have any moons. Okay. Mercury and Venus don't have any moons. So we've only got 1, 2, 3, 4, 5, 6 planets that have moons. How many do you think? Someone's saying 54, someone's saying 184, 112, 200, 56, 111. Well, let's have a look, see who is the closest. Oh, I think we've got one quite close there. Another one quite close. So in our solar system, okay, the closest I think I have seen is 58. In our solar system, this might be something else to make a note of. Guys, when I write stuff on the board, I'm always assuming that you know those are important things that we might want to write down. There are 62 moons. Okay, so there's 62 moons in our planet. So if you have a think about it, those don't have any. We only have one. So we have 5 planets that have 61 moons, because we obviously have one. 61 moons between those 5 planets. So they have lots of moons. Okay, now we have one. Saturn has the most. Okay, and Saturn has the most moons. Wait a minute, I'm going to go back. Mr. B is wrong. Rarely happens, I know. Okay, 62 moons is how many Saturn has. Okay, just realised Mr. B didn't check it. Okay, because there's a lot of people who got the right answer there, and they're probably kicking off in the chat if I have a look. So Saturn has the most, okay, with 62 moons. Okay, did anyone kick off? No one kicked off. Okay, so Saturn has 62. There are actually 200 moons. Okay, in the solar system. That is loads. Okay, if you think about it, we've got one, and like I repeat again, that must mean that these 5 planets here have 199 moons between them. Okay, so that is a huge amount. Now, our moon, and we're going to look at the moon and stuff, I think next lesson in more detail, but our moon controls the tides as well. So our moon has gravity, okay, and it pulls the oceans. So as the moon goes round us, okay, when it gets to here, it pulls the oceans this way, and then when it gets around this side, it pulls the oceans that way. That's it, very, very simply, okay? So that's why you see the ocean and the seas come up the beach and then go down the beach, because it depends where the moon is as it is going around us, okay? So the moon actually has a big effect on us. Now, the moon doesn't produce any light at all, okay? No light at all is produced by the actual moon. However, at night, it provides lots of light, and it can be the only light in the sky. How can the moon create light if it's not producing light itself? Complicated question, isn't it? If the moon isn't producing any light at all, how comes when we look up at the sky, it's a little bright? How comes if you're out in the middle of nowhere, sometimes the moonlight, we actually call it moonlight, is the only thing that we can see? Okay? How can that happen? How can that happen? Let's see if anyone already knows this. Some people there just putting one-word answers in the chat, and I know exactly what you mean, but if you want to show me exactly what you understand, explain it, okay? So some people have just put sun in there, okay? That doesn't explain. I know the sun produces lots of light, but that doesn't explain it for me. So can you explain it in any more detail? So someone said sunbeams hit off it and comes towards us. Yes, that's great. What do we call that? Brilliant. Some people said on there. William. Let's have a look. Shay. Your boy Yeti. Jake. Olivia. Scott. Brilliant. Really good answers. Lucy. Loads coming through there now. I forget how delayed the chat is there, so sorry if I missed some of your answers, but it reflects the sun, okay? So we'll have the sun on the other side of us, okay? So we can't see the sun, it's on the other side of the planet, that's why it's night, but the sun, the light bounces off the moon and comes to us, okay? So that's how the moon lights up the sky on a night, okay? And why it's different shapes, again, we will look at that next week when we look at moons in more detail. Now, that's something I think a lot of people know, but what some people don't know is we can actually, as a planet, reflect our light onto the moon, okay? And we call that Earthshine, okay? Earthshine. Now, What that means is because we've produced so much light on our planet now, with all the lights that we have in buildings and big cities like Las Vegas have lights blaring and stuff all the time, think of all that light going up into space. The moon actually reflects some of that back, the same as it does with the sunlight, and that's called Earthshine. And that is why you might have noticed sometimes you can see the moon during the day. Sometimes you look up, could be in the morning, could be before the end of the day, and you can see the moon in the sky. Now, the reason you can see the moon in the sky, it's not, we can see the sun is brighter, okay, so we can see that, but it's because our light is actually bouncing off the moon and coming back to us, and we call that Earthshine. So if you ever wondered why you can see the moon during the day, it's because of all the light that we produce on Earth, okay? So years and years and years and years ago, that would happen less, but as we've got more technology advanced and there's more lights on our planet, that happens more and more and more, okay, which is a really cool fact. Now, the moon takes 27 days and 8 hours, to be precise, to go round the Earth, okay? And the way it goes round the Earth is in a sort of egg shape, so it's not a perfect circle all the way around, okay? It's not a perfect circle, it's sort of a little bit egg-shaped. And that's why sometimes the Earth, the moon looks bigger, okay? You know, sometimes you have those super moons and those big moons. So if we had the Earth here, okay, if you can imagine if the moon was going around us like that, okay, make that a little bit more, okay, it's the same distance all the time. So when we look up in the sky, we would see the moon as the same size. However, with it being more egg-shaped, press my egg shape. Looks like an avocado, doesn't it? Or a fried egg, one of the two. Okay. Imagine this is Earth. There's us, Europe, Africa, America, South America, and the Antarctic. Okay. So imagine that's the Earth, and the moon's going around us like that. So you can imagine when the moon is here, it looks quite far away. It's quite small because of this distance. However, when it is around here, it is closer. You can see that from the arrows, it's a lot smaller, which means it looks bigger. And that's why sometimes when we look up in the sky, the moon looks different sizes. It isn't actually changing size, it's just changing how far away it is from us, okay? As a great person once said, really close, far away. Probably none of the teachers get that one. Probably they don't even get that one. I don't think Mrs. Carthy's there, I think she would have. Okay, now I mentioned a few times the way that the planets go round, the planets go round the sun. I've talked about how the moon goes round the planets, okay? Now we call these their orbit, okay? So they're orbits. And that's how we spell it, O-R-B-I-T. So the way the path a planet takes around the sun, the path moons take around our planets, okay, those are called our orbits. Now, what do you think creates these orbits? Why are we traveling around those, okay? Because we haven't got an engine, okay? Pop it in the chat, have a think, tell someone, write it down, depending on how you're watching the video. We haven't got an engine on the back of the planet, okay? We haven't got someone sitting at the front, putting it in gear and driving our planet round. We haven't got boosters on the back, or we haven't got someone pulling us around. So how does our planet, why does our planet go around the sun? Why does the moon go around us? What is it that creates these orbits if we don't actually have some power or anything pushing us around? Let's have a look to see if we know. Well done, Poppy. Well done, Seb. Francis, oh, I've got some before then. Amelie, Leah, Jasmine, Isabel, Eleanor. Well done, Freya. Really writing out your answer there, okay? Giving us some really good answers there, Mrs. Rice. I agree with you. There's fab answers in there, okay? So it is gravity that is causing us to do them, okay? Now, all planets have, actually, let's go back. Every single thing creates gravity, okay? So these planets are creating gravity. We are creating gravity, okay? This pen is creating gravity. This is creating gravity. Every single thing creates gravity. However, the bigger something is, the more what we call gravitational pull you create, so the stronger the gravity you produce is. Okay. Now, with ourselves, and even with big trucks, big buildings, things like that, the gravity on those is absolutely tiny. It can't really affect us. Okay. You're not going to walk past something that's really big and get pulled into it on Earth. It's not going to happen. Things have to be the size of planets, okay, in order to start creating enough gravity in order to pull things towards them, in order to pull us down towards the Earth, in order to pull the moon around us, okay? So, the bigger an object, the more gravity that it produces, because they have a stronger gravitational pull. So the sun, now I've only drawn a quarter of the sun here, because we're going to talk about that in a minute, but the sun is massive compared to all the other planets. I'm going to tell you exactly how much in a little bit, but it is absolutely massive. So it creates so much more gravity than all of these planets. So its gravity pulls us around, okay, and it's a gravitational pull that is making us go around, okay. Now, as well as that, we create gravity, so we are pulling the moon around us. So when I mentioned which planets have the most moons, Saturn, which is the second biggest planet, happened to have the most. Saturn's bigger, so it has more gravity, so its moons can be bigger, so it's more likely to have more moons, okay? Jupiter would have the strongest gravitational force, but with moons, it happens to be, look where the planets would go in there to get stuck in an orbit, okay? So that's why the planets go around us. Now, the first thing that I've got to say, well, not the first thing, because I've said loads of things, so I'm just talking nonsense, but what I've got to mention now when we talk about orbits is the planets, because when we look at the planets, a lot of the time we will see them like this, okay? See them in our straight line, and a lot of people think that's how they look, and it is not, okay? We are not all going around the sun in a straight line, okay? We are not doing single file. That is not what happens. So we have our sun in the middle, okay? And I'm going to draw these a lot smaller. So we have our sun in the middle. And then we have our orbits, okay? So 1, 2, 3, 4, and there's a little bit of a gap, so I'll make it bigger. Like I said, these aren't drawn to scale. 1, 2, 3, 4, 5, 6, and I'm going to stop there. Okay, there's obviously another 2. I'll just draw the bottoms of them. Sorry, I'm joking in my head. Okay, so we have the planets. So when we look at them like this, it would look like they go there, all the way along. Now, the reason they're always drawn like this is because this is how far they're away from the sun. So our first planet, Mercury, goes on this one, okay? And our last planet, Neptune, goes on that last one. So you can see Neptune is further away from the sun all the time than Mercury is. So that's why it's easy to draw them like that. However, the planets won't be. So I will use, let's have a look. I think this colour's quite good. Just going to use the same colour. I'm not going to do all the colours, it'll take ages. So Mercury could be here. Here. We could have Venus there. We could be here. We could have Mars there. Okay, Jupiter could be there. Could have Saturn here. Okay. Oh, I've done Neptune first, don't know why. And some of them might be lined up, so I'll put there. But our planets can be at different points around this. Now, as you can see, this circle here, this orbit, is smaller. So this planet, Mercury's orbit, isn't as long as how long it takes Neptune to get around. Neptune takes ages to get around because it's got a much longer path. So if they all start at the same place, Mercury's going to get around quicker than Neptune, isn't it? So that's why the planets are all at different parts. So sometimes they might line up, certain planets might line up, and it's why certain nights you can see some planets in the skies and not other ones. But they go around there, and at different points it can be different. So don't think that they are always in a line place. I don't think that you probably did, but that's what they sort of look like a little bit more. So I'm just going to go back to the Earth for 2 seconds. Now, our Earth spins, okay, and it takes 24 hours for it to spin around a day, okay? Again, something that we probably already know. And that's why we have day and night. When we're facing the sun, okay, we have day, obviously. If you're here, your day, when we spin around, you would be in night. Simple. However, it spins on an angle. What I mean by that is if we have the planet, I'm just going to do it blue, not going to put my continents on there. Okay. If we had that, okay, it doesn't spin around like here, it is slightly at an angle. Okay, so it spins around like that. Now I put that on a little bit more of an angle than it actually is, and that is because I think it's around about 41 degrees, but don't quote me on that, okay? That is just off the top of my head. I think it's around that, okay? So that looks more. So it doesn't spin around like that, it sort of spins a little bit, okay? Now this, with our orbit, okay, so us being on a tilt, as well as our journey around the sun, which is what takes a year, okay, that is what causes our seasons, okay? So autumn, January, spring, summer. Can you tell me, and you've got summer because it's never in England, okay? Can you tell me, why do you think that is? Why do you think the fact that the Earth is slightly on a tilt, okay, and we are going around the planet, the sun, okay, why does that give us the seasons? Why does that give us snow and cold in winter? And why does that give us sun and summer and hot weather? And we have those two sort of periods in between where it's changing into the two. How can just a simple tilt and our journey around that do that? And if you're extra knowledgeable or extra clever because you're working it out, because you're thinking logically, you're thinking like a scientist, why does that mean when it's summer in the top half of the Earth, it's winter in the bottom half? Some of you might not have known that, but Australia has the opposite seasons to us. Well, when we say, oh, it's summer, the hottest time of the year, it is actually winter for Australia. Still quite warm for them in certain places, but it's their coldest time of year. Do we know why? I think it was starting to write something there. Amelia wrote because the tilt changes. Let's have a look. Let's have a look. Good answer. Starting to come in there now, Francis. Because we move around on the axis and slightly move it on the slope. So the sun is facing one side, it's the opposite side. Because the tilt makes it get colder as it tilts more. What is it about the tilt that causes that? Okay, I'm going to start timing some people out because I can't say all the answers because we're talking about other things. Right, okay. But so Freya mentioned there because it might be on the other side of the planet, so when we're facing the sun, it's not. But that would mean they have night when we have day, wouldn't it? It wouldn't explain why their season is different. Okay, so a few good ideas there, I'm going to let you know. So, if you have a think about it, if we have our, I'm just going to take a few of our orbits out here. So if we have the sun there, okay, and we have the Earth here, and we're on a slight tilt, okay, and we as, we as the United Kingdom are sort of on the top half here, we'll see about there. You can see, okay, when we are on this side of the Earth, we are tilted away from the sun. And when we're tilted away from the sun, we're further away. It means it is going to be colder, okay? If we move the sun to this side, okay, and remember the Earth spins over there, okay. When we have daytime here, you can see we are tilted towards the sun. So when we are tilted towards the sun, we are closer to it, and that's when we get our summer. So that tilt in our orbit is what causes our seasons. Okay, some good ideas in there. Now, last couple of things. So, the sun is the center of our solar system. It's the center because it's the biggest thing in our solar system and it pulls everything else around it. So that's why it's in the center. Now, it has a diameter, and again, something you might want to write down. We'll put it over here, of, let's have a look. Make sure I'm getting enough zeros on here. It has a diameter of 880,000 miles. Okay, that's such a big number. It's hard to sort of understand what it is. So to give you a little bit of a idea, 7972. Okay, that is the diameter of the Earth. So the Earth, remember, diameter means from one side through all the way across, so that's our diameter of that planet. Okay, of Earth is 7,972 miles. Okay, so you know how big our planet is. Okay, that's massive. Okay, the sun is 880,000 miles. Okay, so much bigger. It is absolutely huge. Okay, it's so huge, can't imagine how big it is, which is why we can see it in our sky and we can't see other planets as much because they're nowhere near as big as it. So what the sun is actually is a ball of burning gas, okay, that's held together by, you guessed it, gravity. So because it's that big, it has a massive amount of gravity that is holding all these gases. Now on our planets, our gases tend to float around and leave, okay? You have different gases, denser gases and lighter gases, but they tend to float away and you can't see them, they're invisible. However, because there's so much gravity on the sun, it's all held together and it's burning, and that burning of the gas is what produces the light and produces the energy that we get. Okay, so the actual light you see from the sun is burning gas. Okay, the same way if there was a gas fire or something like that, or your cooker, if it's a gas hob, when you light that, you can see the light from the flames, can't you? It's the same thing. Gas is being burned, producing that. Now, the sun is actually a star. So when we look up at night, we see stars. Okay, we see hundreds of stars, depending on where it is. If you're somewhere in the countryside where there's not much man-made light or anything like that, you can see obviously a lot more. But there are stars all over. The sun is actually a star. Okay. However, this star is a lot closer to us than all the other stars in the sky. So the stars are all like the sun. They just, I'm going to tell you how far away they are, but they're very, 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 very far away from us. Okay, the actual closest star to us is 4 light years away. Okay, 4 light years away is the closest star to us that they found. Okay, so you might say, oh well, 4 doesn't sound much, but it's a light year, and I'm going to explain a little bit what light year is. So we're about I'm just going to check that because I think I've knocked up a number there. I don't think my note is right. Okay, I didn't. Okay, so we are 150.92 million kilometers from the sun. 150.92 million. So 150,920,000 kilometers from the sun. It takes light, okay, 8 minutes and 20 seconds. 8 minutes and 20 seconds to travel that distance from the sun. So when we get sun, okay, we can see and lights up our planet. That has took 8 minutes and 20 seconds to travel 150,920,000 kilometers. That's how quick light is. Okay, so if that is how far light travels, in 8 minutes. What a light year is how far light would travel in a year. Okay, so if you can imagine, okay, 150 million 0.92 in 8 minutes, how far would that light travel if it had a full year to keep on going? That is a light year. Now the closest sun, other star, sorry, is 4 light years away. So that is how far away all these other stars are. Okay, so the closest is that one. Now, all of like our sun, we've got 8 planets following it. There are there is possibility of different planets, okay, going around all those stars, but obviously they're so far away and so small and not producing as much light, we wouldn't be able to see them. Okay, so all of those suns, stars, sorry, that you see in the sky, they could all have planets around them, we just can't see them. Now it's estimated, because they don't know for exact, okay, that there are 100 billion stars, okay, in our sky. So I'm going to write that number down just so you can see it. Okay, sorry, orbit. So there are 100 billion, which is, well, there's our millions, there's our thousands, there's our hundreds, thousands, millions, billions. Okay, 100 billion stars in the sky, and on average, there is roughly, they think, about 1 planet per star. They can't say for certain, okay, because they can't check every single one. It's impossible at the minute, okay? In the future, I don't know. But there are 100 billion stars, okay? Each has, they think, on average 1 planet. Some might have none, some might have 8 like us, some could have loads. It could be massive and could have 20 planets, okay? So that would say if there's average on 1, there are roughly probably around about 100 billion planets in our solar system. Okay, so with all those planets, there are, I'm not going to go on, should we say there's aliens or anything like that, but there is so much chance for so many different things where there could be other life and stuff like that. It's just so far away, we might never ever meet it. Okay, so there are a ridiculous amount of planets and stars in the solar system. So that's sort of the bit of science that we're going to look at today. Now what we're going to have a quick look at, and it's only going to be a quick one, it's not going to be a full lesson of topic like we would normally do if this lesson was on a Thursday. I've rubbed out Earth, only one I've rubbed out, don't know why. Okay, but we're going to have a little look at Tim Peake, and I'm going to give you just a few facts about him, and then more facts are going to be in with the work that you're going to be doing today, kindly provided by, who did the science this week? I think Miss Rice did our science work, and Mr. Donaldson did our Tim Peake work, and I did the kahoots. Okay, so we're going to be looking at there's some work there for you on Tim Peake. Okay, now if you don't know, Tim Peake, well, sorry, let's give him his full title, Major Tim Peake. Major Tim Peake was the first British astronaut for 20 years when he went up, let's have a look there, he went to the International Space Station on the 15th of December 2015. And when he went up there, he was the first British astronaut in 20 years. Okay, now Major Tim Peake, because he was originally part of the British Army, and when the British Army realised they were decided they were going to put someone into space, they had people from the army apply, and 8,000 people applied. Major Tim Peake was the one who was lucky enough to get picked to go into space. Okay, and when he was picked, he had loads of time and loads of training that he had to do to get ready to be that astronaut and to go up into space. So when he went up there to the International Space Station, which is a space station which travels in orbit around our planet, he spent 6 months there, and he was doing experiments. Okay, 6 months on, and for short they call it the ISS, the International Space Station. Okay, not International Superstar Soccer that I used to play. It is the International Space Station. He spent 6 months on there, and when he was there, he was doing experiments, which they do sort of all the time on there, and a lot of the time as well, keeping in contact with schools. I'm just going to write all sorts, because I remember when he was up there and he was on TV shows and he was doing museum things. He was doing absolutely loads. So he was conducting experiments, which he always do on the ISS to see how things work in space and to do things that they couldn't do on Earth. But he was also, a big thing was keeping in contact with schools and keeping in contact with lots of other different things. Now, he spent 6 months there. Now, astronauts can spend longer than 6 months in space, but they tend to do 6 months and then come back. And that is because it has people who've been just over a year, I think it's the longest, about 400 days or so. But when you're in space, it affects your body, okay? Because you haven't got gravity, and if you haven't got gravity, you're not using your muscles to walk, to keep yourself upright, your bones aren't doing all that. So your muscles and your bones, things start to get weaker. So the longer you are there, the harder it is to come back, okay? So that's why he spent 6 months. That's why people tend to spend 6 months. Now, he returned 6 months later, so 18th of June 2016. And when he came back, he was seen as a little bit of a national icon, national hero. Now, our topic that we are doing is people that changed the world. Now, we looked at Franz Ferdinand, whose death had caused World War One. We looked at Jane Goodall last week, not in a lesson, but the work was there for Jane Goodall, who was a person who did lots and lots of research and things into chimpanzees and those type of things that really helped bring on that field. Now, Tim Peake went into space, but lots of astronauts go into space and do these experiments and stuff like that. So why are we classing Tim Peake as someone who changed the world? In the chat, okay, can you write down, why do you think Tim Peake changed the world? How could he have changed the world? And I'll give you a clue. It's something that I mentioned here, okay? We, myself, Mrs. Rice, Miss Carthy, Mr. Donaldson, Miss Allison, we all thought that this was someone who was worthy to say, we think he changed the world, okay, because of something that we've mentioned. All right, can you pop it in the chat, or can you just have a little think if you're watching it back on the replay or anything like that? Why is it, do you think, he changed the world? Why was it he was so, we see him as such an important person? Because I just think so. Someone's mentioned the experiments. Wasn't the experiments, okay? Some of the experiments he could have done are likely to be chosen by different people, by very clever scientists and things back at home, the things that they want to test, and he would have been doing them, which could help, but they wouldn't necessarily have been his. He didn't prove science wrong, no. So he was the first person to go into space in 20 years, British person. But obviously, there's been someone before, so why didn't we look at them? Why have we focused on Tim Peake for the minute? Okay, William, you're out of ideas. Sorry, matey. Wasn't the first person in space. So what I'll tell you is, the reason we picked him is because in order to change the world, you don't always have to be to do something amazing, to do some, well, in what some people think is a massive thing that changes the world, like stop this or do this one. Just seen Millie and Isabel P. Brilliant answers there, just as I was about to say them, okay? Tim Peake is a great man, okay, who had to obviously be really, really good to get into space, but he's changed the world because he spoke to schools, he spoke to museums, he spoke to all these people. He inspired loads and loads of people to get interested in space, okay, to get interested in science, to get interested in becoming an astronaut, all of those things, okay. Now, at the minute, those people, we don't know, those people are likely to do something better in this world, okay, to help it with science, to help it with becoming an astronaut. They might not become astronauts, but if they're interested in science, then they're becoming engineers and things like that. So he's inspired so many people in a really, really, really good way, okay, to do things that they might not have done before, to do things that are going to help the world. And for us, we thought that that is someone who has changed the world. Okay, it doesn't have to be that you change something that had been wrong for years, that you started a world war, that you stopped a world war, anything like that. People change the world on a daily basis by inspiring other people to do the right thing, to do good things. And Tim Peake is an amazing man, because obviously he's an astronaut, and he's a very smart man, and he's a lovely man as well. All the interviews and things I have seen with him, everyone says those type of things about him. So he's a great man, but he's inspired so many people because he went out there, and his skills and his talents and all of those things, he let the whole world see them and see how interesting they are, and go out and speak to people and get those interested. And that is why he's changed the world, because those people are probably doing things with their lives that they weren't going to be doing before. Okay, and who knows, in 20 years time, some of the people that he was inspired might be great scientists who actually do something that cures something that we'll be doing, or manages to invent something that revolutionizes the world, all because they were inspired by him. So that's why we chose them. Now, that was just a little look at Tim Peake. I know it wasn't a lot, but we're going to get on to the work for the day now. So in the description below, there is 2 links, a year 5 and a year 6 link to our Padlets, where we have worksheets. Okay, now we have some work on the science, the planets that we looked at, and we have some work on Tim Peake. Now, normally we do these as 2 separate lessons, but obviously the bank holiday has made me sort of put them into one. That's why we didn't look too much into Tim Peake. So there is work there for science, and there is work there for our people who change the world. However, you don't have to do it all today. You can choose which one you want to do. Okay, you might want to do the school one first, so science one first, then you might want to do the Tim Peake one afterwards, or vice versa, whichever's up to you. Okay, you might do one today, one tomorrow, you might do one this morning, one this afternoon. Entirely up to you. You can choose, but the work is there on the Padlet. And I've checked the Padlet links to work this time, so you can go down there and check. There is a Kahoot. The Kahoot is for the science. So if you've been writing notes, I would say do the work first. Let's see who can get on the leaderboard for next week in science. Okay, your top 3. So it's all about the planets and, well, all the little things that we looked at today. Okay, next week's science lesson, we'll be looking more at other things. The moons and things like that. Okay, so we're going to look more in depth into things if that's just whetting your appetite. Now, if you do need help with the work, pop it in the comments, like I say, or go to Twitter, go to Instagram, go to Facebook, Mr. Binghams123. You can ask me questions on the work or anything like that, and I can help you out. You can ask on the Padlet where the work is, so you can comment on there and ask for help. And there's an email address on that Padlet as well if you want to send us some work or anything like that. One task that I would like you to do, okay, that isn't in the packs or anything like that, and you can choose to do this, is can you send me some pictures? And I'm going to post it. If you notice that if I get a certain piece of work, I ask you to send me in. I post it on my Twitter, my Instagram, things like that. This is one that I want to send in for this one. Can you make a picture or whatever it is you want to do of the solar system? Okay, draw the planets on and write some of the facts that you've been learning today around them. That's what I'm wanting you to send in and have to my Twitter and my Instagram and my Facebook. Send those in to me, and I'll get some really good ones up, those brilliant art things and stuff like that up the other week. So get those in, and then once I've got them all in, I can get them up online. That would be brilliant. Couple of notes before you go. I'm going to stay around if there's any questions or anything like that in the chat. But remember, please, can you now, okay, now, to make sure that the adults don't take over, before you go doing work, comment on the video, okay? Well, firstly, like and subscribe. Comment on the video, okay, a song choice for Friday, okay, for the stay-at-home street party. Put your song choice on. If your username is not your normal name, just put your first name, just your first name, please. Just your first name. Put your first name in there. Some people asking for the Kahoot. I've just mentioned there. It's down in the description. The link to the Kahoot tells you how to get there and what you need to do. Okay, there's a link for it. But yeah, pop a comment now on the video of the song that you want, and I'll pop it in. I need these song requests in before. Okay, my music catalogue that I used to use when I was DJing years and years and years ago. Those are all CDs. Those are all gone. Those are all old. Can't use those anymore. I need to get the music before Friday, so if you ask for a song on Friday, if I haven't downloaded it, I might not have it and might not be able to get it, so you need to let me know before. That's why I keep going on about it, so I can get them downloaded, okay? So mention that one. TikToks are coming. Tomorrow as well, there are 2 lessons. We're going to do my English writing in the morning because we're going to have to do it on Friday. But on the art lesson on the afternoon, have a look on my Twitter, have a look on my Facebook. I've told you what you need. You can't just come along with pen and pencil on tomorrow afternoon. You need some toilet roll tubes, okay? You need some masking tape. I'll finish off the one that I'm doing today and I'll put a picture of what we're going to make. Masking tape and a couple of other things, okay? But those are the main things that you need. Okay, check my Twitter, check my Facebook, check my Instagram. I'll pop them up there. If you can't get them for tomorrow, that's okay. The video will stay up. You can do it later, okay? So, I think that's all my messages done. I'm going to go to the chat if anyone's got any questions or anything like that for a few minutes, okay? And then we'll get on. If you're going now to get on with the work, song comment, please, and go. Okay, get on with the work. Ask any questions through the socials. You need them. Okay, this is the best part of the video where you just see my floating head. Oh. Yes, sorry, I didn't mention the Safe Homes 3 party is 3 till 4. Thank you, Miss Rice. I've got that many things to go through. Didn't even mention the time. Okay. Oh, well, happy birthday for tomorrow, Freya. I don't think it's our Freya, another Freya. Happy birthday for tomorrow. But obviously, if you're in any of the lessons tomorrow, remind me and we'll maybe everyone will sing from different parts, maybe. You're welcome, Iris. Happy birthday to your dog for a week ago, Iris. Joseph, art is tomorrow at 2 o'clock. And remember the things I mentioned. Keep an eye on my Facebook and Twitter if you can't remember them. Toilet roll tubes, 3 or 4, some masking tape, or some other tape, some glue, and so a few other things. Look at my Twitter, look at my Facebook. I know actually that your dad liked a few posts, so it must be on there. Or it might be you using your dad's account. Okay. So keep an eye on that. I'm going to pop another one up to date just after the time of everything that you need to try and remind people. I'm a Sunderland supporter, Mason. You don't need toilet roll, Joseph. You see the toilet roll tubes. Mason Euro, someone has to, eh? Only joking. Good to know, Isabel. Go and put a donk on it. Right, guys, I am staying around for questions mainly to do with the science. I'm very flattered that you're interested in things that are inspire me and things like that. But please, if you're okay with the work we're doing, want to have a go at the worksheets or the Kahoot for me. That sounds like Mr. Alderson, Isabel. Definitely sounds like Mr. Alderson. Hi, Vinny, didn't see you down there. It's good to see that you were in. Bye, Vinny. You don't need paint for the art lesson, Tom. If you've got some, you can use it. But in the art lesson, because clearly it's when you can see what it is. In the art lesson, I'm going to show you how to make something, and then you can decide how you want to decorate it afterwards. Okay, so you can use paint and stuff afterwards. So you don't need it for the lesson. Okay. Share for the worksheet for the work on the science. If you go to the Padlet and go along to science, okay, all the work will be there. I can't remember the work, whether it's in the worksheet or whether it's in the PowerPoint, the questions or the tasks in there. If you really can't find them, remember, do the task that I asked you to do. So make a picture of the solar system and put in loads of facts that you've been learning today around it, okay? And then obviously send me a picture if you do that. It would be brilliant to see your great work. See you later, Jude. I hope when I check the comments here, there's lots of song choices after the video. If you're still in there now and you haven't put a comment on, please put one in. Millie, I know you've already asked for actually one song, 2 songs. Okay, 1 song. Millie, you asked for a song for your sister, but you haven't asked for a song for yourself if you're still there. Make sure you ask one for yourself as well. Right, guys, looks like I've answered all questions, things that you have there. If you still have some more, again, mention it all the time, but there's my socials. So Twitter, Facebook, and Instagram, Mr. Biggins123. Search for them there. You can send me a picture if it's a worksheet you're stuck with or anything like that. Any help that you need. I'm going to head off now. Make sure, please, that you send me your pictures, your solar systems with the information on, and any other work that you do. It's great to see, and I will pop them up on Facebook and Instagram and Twitter, okay, in the next couple of days. Please remember your song requests. See you tomorrow for our English lesson and then our art lesson, and then Friday is our stay-at-home stream party, which everyone's getting excited for. So great to see you all down today. And okay, stay safe. Any help, just let us know. See you later.